Yesterday we looked at how to find the greatest common factor, and today we're going to look at how to factor that out of certain polynomials. So let's look at letter A, and if the greatest common factor is just 1, we're just going to rewrite the polynomial because that's how it wants you to do it on your IXL. So let's find the greatest common factor of 4x and 12, and then we're going to factor it out. So let's start off with the coefficients. What's the greatest number that will divide evenly into 4 and 12? And that would be 4. So I can factor out the 4 from each term. So if I take 4x and divide it by 4, that would leave me with 1x. And then 12 divided by 4 is 3. Then you can always check it by remultiplying it back out. So if I were to distribute this back out, I would get 4x plus 12, which is what we started with. Okay, moving on to B. I could factor out a 10 out of both of these, and they both have an r in common. So my greatest common factor would be 10r. Then let's write what we would have left in the parentheses. So 10r squared divided by 10r. Well, 10 divided by 10 is 1. And then r squared divided by r would just be 1r. And then I have negative 10r divided by negative 10r. Well, negative 10r divided by positive 10r would just be negative 1. Like I said, always mentally check yourself by redistributing it back out. 10r times r would be 10r squared, and then 10r minus 1 is negative 10r, which is what we got at the very beginning, so we did it correctly. Okay, moving on to C. This one looks like you probably couldn't factor anything out, but you actually can. Since they're both negative, we can factor out a negative 1. So you're basically just changing the sign of each term. Negative x divided by negative 1 would become positive x, and negative 7 divided by negative 1 would be positive 7. Moving on to D. The greatest common factor of 16n cubed and 4n squared would be 4n squared. So then we can divide that out of each term. 16n cubed divided by 4n squared. 16 divided by 4 is 4, and then n cubed divided by n squared would just be n. And then negative 4n squared divided by 4n squared would be negative 1. Okay, letter E. We are looking if there's a greatest common factor between 2 and 11. Both of those numbers are prime, so there is not a common factor besides just 1. So I'm just going to rewrite it. Not a GCF besides 1. Okay, letter F. So all of these have a 3 in common. They also all have an x. So we can factor out a 3x for the greatest common factor. 3x cubed divided by 3x would be x squared, because 3 divided by 3 is 1. And then you had x to the cube divided by x, which would give you x squared. And then negative 9x squared divided by 3x would be negative 3x. And negative 3x divided by positive 3x is negative 1. Okay, then let's do a mental check to make sure we did it correctly. 3x times x squared would give you 3x squared. 3x times negative 3x is negative 9x squared. And then 3x times negative 1 is negative 3x. So that's what we started with. Alright, last example, and these are going to be like 90 above, I think, on your IXL. So let's find the greatest common factor first and then factor it out. So what's the greatest number that would go into 13 and 39 evenly? and that would be 13. Then we have to look at each variable and figure out what they all have at least in common. So this first term only has an a, so that's the only variable that we could factor out of all of these. Actually, they don't all have an a in common. There's not a variable that they all share. See, the first term has an a to the 7th, the second term has a, b, and c, but then the last term only has b and c. So the only thing we could take out of this is just a 13. So if I factor 13 out of this first term, I would just be left with a to the 7th. And then negative 39 divided by 13 is negative 3. And we're not doing anything to these variables because they don't have any variable in common. And then once again, negative 39 divided by 13 would just be negative 3. That one was a little bit tricky. All right, that's it for the notes. Have a great day.